Hey guys, welcome back. So we're going to do paper 2 of the tough paper grade 9 paper 1 that I did last week. So if you haven't seen that, I'll leave the link in the description, as well as a link to 9 other grade 9 papers that I've already completed, where you'll be able to get the paper and then also see the way I work through it. And that's the really important thing about grade 9, is it's not really about the math processes. If you're aiming for a grade 9, you probably already know how to factorize and expand and do cosine rule and all that stuff. But it's knowing what to do and why you do it. So when you're watching these videos, the best thing you can do is listen to my thought processes. What I've done is I've gone in blind, which will allow you to see exactly how I approach questions. Because it's not that I can look at a question and know instantly what to do. Instead, it's about working out what to do, especially with the harder style of questions. So keep that in mind, and without further ado, let's just get straight into it. So island X is a small island. In the winter of 1986, the ratio of natives to tourists was 7:1. In the summer of 1987, the ratio of natives to tourists was 155 to 69. In between 1986 to 87, the natives decreased by 100 and the tourists increased by 220. So find the number of tourists that were on the island X in the winter of 1986. Okay, so this question involves basically looking at the change in the number of parts and comparing that to the number of the population change, right? So sometimes if you're lucky, they might only increase the number of tourists or whatever the equivalent is in your question, in which case you can just compare the number of parts, and that's quite easy. In this one, the tricky part is the fact that both numbers have changed, right? The number of natives and tourists. So how would I approach this? Well, I'm not sure what to do yet. So what I'm going to do is I'm going to write out the information in a way that makes a bit more sense. So I'm going to write 1986 and 1987, just to kind of look at the overall change. And then I'm going to write natives and tourists as N and T. So the natives to tourists in 1986 was 7:1. And in 1987, it was 155. Again, natives to tourists, 155 to 69. Okie dokie. So we're trying to look for the number of tourists. So it might make sense to write these as fractions of each other. So for example, n would be 7/8 here. And it would be 1/8 for tourists. Whereas over here it would be, well, this is where we can use our calculator. It's paper 2. 155 plus 69 gives us an answer of 224. Okay, so we have 155 as a fraction over 224. And then 69 over 224. Okay, so I've written them all as fractions, which is pretty helpful. To be honest, I don't know if I'll need it yet, but it is a good thing to do just so we can visualize it. So if I'm looking at this, they give us information about the number of natives and also the number of tourists. So what I'm thinking is, what if we say X is the, since we're using island X, let's just say X is the total number of people. So total, it would have to be initially on the island. Okay, and I've got a feeling I know what to do now. So what do I mean by that? So we don't know how many people we start off with on the island, so I'm going to say it's X. So that's the total number of people that initially in 1986 are on the island, right? So right here, in total, that makes X people. Then what happens? Well, we have a decrease in the number of natives and an increase in the number of tourists. So if we're looking at the total number of tourists and how it changes, we can make an equation. How many tourists will there be initially? Well, there'd be 1/8 of the total initially. So we're going to write 1/8 of X, right? That's how many we initially have on the island. Now, in 1987, 220 more tourists come onto the island. Does that make sense? So again, just to go over it, total number of tourists initially, and then 220 get added. Now that should be equal to the fraction of tourists that are on the island in 1987. So that's 69 over 224. Now what do we times it by, right? Because it's not just 69 over 224. It's of the total number of people on the island. So how many people on the island? Well, we've got X, we've added 220, and then we've taken away 100. So let me run through that logic one more time. I've managed to find an equation for the number of tourists in 1987, and I found 2 separate equations, which should be equal, because the number of tourists in 1987 is the same, right? Initially, it's an eighth of the initial population plus 220 because we have this ratio here. Okay, and we plus 220 because it tells me 220 more tourists arrive. The other equation we have, because we have this other ratio, is it's 69 over 224 of the final population, of the population in 1987, which is X, the initial population, add those 220, but then take away the 100 that left as well. Hopefully that makes sense. Now we have an equation, we can actually solve this. So the first thing I would do, I'll do this in a few kind of key steps. We want to solve for the initial population, because using that we can then work out what fraction of the population in 1986, which is initially was tourists. Yeah. So that's also another reason why using X as the initial would make sense as well. And then that would just be X plus 120. Expand the brackets, and we're just going to solve for X. So going through the motions here, plus 220. They're ugly numbers for sure, but remember, it is a calculator paper, so it doesn't really make a difference. So what is 69 over 224? So 69 over 224, whoops, times the time, there we go, times the 120 we have over here. That would be, let's leave it as a fraction for now, 1035 over 28. Because if we have a really long decimal, it means we can't really solve that easily. I'm not sure which one's bigger. So I'm just going to minus 69 over 224x on both sides. So what is 1/8? Okay, I'm going to do something clever here. Use this. I'm going to go back to here. I'm going to say, whoa, okay. Minus. And then we're going to do 1/8 minus it. And that'll give me how much x on the left-hand side. Okay, so negative. That's totally fine. Minus 41 over 224x. Equals, and then it's going to be 1035 over 28 minus 220. Because again, don't forget, we're just minusing both sides. Ooh, whoa. Over 28, there we are. Minus 220. That'll also give me a negative number, which is good because it will cancel. And then I'm not going to rewrite anything. I'm literally just going to do answer. So ANS divided by this. So I'm going to put this in brackets because don't forget, calculators are a bit dumb. They don't really know what you're doing. So if you put it in brackets, you force it to work out this first, then divide it, which is what we want. That's what I'm intending. Gives me 1,000. Perfection. So there were 1,000 people initially on the island. And how many of them were tourists? It was 1/8. So tourists equals 1/8 of 1,000, which is 125? 125. So there were 125 tourists initially on the island. Pretty tricky ratio question. But again, you're always trying to form equations in maths. That's all you're trying to do, and then solving them. Pretty tricky Venn diagram question. So we have a Venn diagram that's given all in terms of x. And we are asked to find the probability of B and not A or C. And this can be tricky because if you work out the wrong probability, you don't get the very final marks. Just so you're aware, this is a 5-mark question. You can get 4 without knowing which probability it is. And that's really, really important, okay? Or maybe it's 3 depending on the mark scheme, but 3 or 4 depending on what the exam will decide that year. So, what does this mean? Well, first of all, look at the first bit, B and not A. Well, that means it's an intersection between B and everything that's not A. So that would be this section over here. Now when it says or C, that means it adds anything that isn't in A but is in C. But if you look, there's no other overlap between C and B, right? So it would add these two, but we have this not A which cancels them out. So it is actually just this final thing here. So what we're looking for, our end result, is whatever x over 5 equals. Okay? And if you want to get a mark, kind of cheekily, you can literally just write this equals x over 5. And then once you work out x, you sub that in, you get your final mark. So the question is, how can we work out x? Well, this is a really common type of question, actually, except they normally give you numbers. But there's no reason why they can't give you x's, because it actually doesn't make it any more difficult, especially if there's no x squared. Now, if there's x squared, it makes it slightly more difficult, but you know how to solve quadratics anyway. So it makes it more tedious than anything. every probability on a Venn diagram has to add up to 1. So if I add all of these x's up, so x over 2, x squared plus 2, blah, 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 it should equal 1. So this is actually just solving quadratics. That's it. The only tricky bit, the only additional part, is the fact that you have this part at the beginning, and reading these can be a bit tricky for students. So I agree with that. But remember, that's only 1 out of 5 marks, really. Or let's say 2 out of 5 marks. You can still get 60% without knowing any of that. And bear in mind that this is one of those unseen questions. That means you're getting 60% of that, so 6% extra out of the 10% available. That's still really, really good, because that's pushing you into that grade 9 boundary. You don't need 100%. 60% of that additional stuff will get you a grade 9. So anyways, let's just add all this up. So we have x. I'm literally going to cross these off as I go along, because I'm very paranoid about missing one. And I'd recommend you do the same, because I've seen this happen in papers from really smart on it students, but they just miss one because there's so much to do. So literally just do what I'm doing, just cross it all out. Plus 2x squared plus x, because it's really, really easy. And then 13x minus 1. Now this is a calculator paper, and that should equal 1. So that actually means what I'm going to do straight away, before I even do anything else, I'm going to do plus 1, minus 1. I'm going to cancel those out, because if I minus 1 from both sides, it will get rid of them, okay? So that'll make both of those 0. Then all I'm going to do is use my calculator to add up all of the x's and stuff like that. X squared plus 2x squared, I can do that as just 3x squared. And once again, there's no harm in using a pencil. I would recommend using a pencil and just putting a light line through it. So you don't want to cross it out with the same pen, because then it looks like you don't want it marked. If you use a different coloured pen, or if you want just put like a tick over it, then the examiner knows, okay, you're just using this to make sure you get the right value. The next thing we need to do is add up all the x's. So I'm not going to be arrogant. I'm literally going to do it step by step here, because it's possible for me to make a mistake. 1 plus 1 plus 1. So we have 3 plus x over 2. So that's another 0.5 plus 2 plus x over 5 would be 0.2. Or if you write a fifth, you'll get the right answer. Don't worry about it. Plus 1 plus 13x. So plus 1 plus 13. Gives me 197 over 10. In fact, because I know I'm going to use a calculator to solve this, I'm going to leave it as 19.7x. Whoopsies, wrong colour. And again, there's no need to be... Again, I use the word arrogant because it kind of shocks people into listening. You don't need to worry about it. Did I really do something that stupid? Did I think that was a plus 1 and it was a plus 13x? Okay. Okay, instead of doing that, what I'm going to do is there's only one other number, it's minus 1. Is that true? Yeah. I'm going to minus another one from it. Thank God I spotted that. That was a really stupid mistake by me. Equals 0. Now that's correct. That was a bit silly of me, but that's fine. We spotted it, and that's the key thing. And then how do we solve this? Well, just use your calculator, man. Like, I wouldn't even bother doing all that stuff. You can sub into the quadratic formula, but if you have this calculator, go down twice, right once, equation slash func. Polynomial, simultaneous equations, different, of course. The degree is always going to be 2 for GCSE. And then just sub in the values, 3. And this is why I didn't use the fraction, because now I can just type in 19.7. Don't need to worry about it. Minus 2. And we're going to get 2 values, right? One is a tenth. So we have x is equal to, let's just call it 0.1. And then we should also get another value. Minus 20 over 3. Well, I can see that because this is probability, it can't be negative. So the probability of A happening by itself can't be negative. So what we're going to do is just write a little note. Cannot be negative. So what was our answer again? Well, it's x over 5. I'm going to write this out really explicitly. That equals 0.1 over 5. But if you look at the answer, it says a over b, where a and b are integers. Now, if you put this into your calculator, it will actually do it for you. So you don't even need to think. Right? It does it for you. But all you're doing is timesing top and bottom by 10 to make them integers. So 1 over 50. That was actually shorter than the previous question, despite the fact that it's worth more marks. Why? Because Venn diagrams and probabilities scare people. But if you notice, did I actually use any probability? It's just an equation, right? Like, I didn't have to say, oh, what possibilities were there or anything. I just wrote an equation. This is probably the hardest bit, which is worth 2 out of the 5 marks, admittedly. But solving for x will give you 3 marks. So again, if in doubt, form an equation and solve it, you'll still get marks. I've zoomed in quite a bit for this one. So the diagram below shows part of the graph of y equals 2f of x minus 1. Interesting. And they want us to draw minus f of minus x. Now, the interesting thing is, a lot of students would try and just go from this straight to this. And could you do it? Potentially. Like, for example, going from 2 to minus 1, you could divide by all the coordinates by 2 and then reflect them to make it negative. And then with x minus 1, what you could do is add 1 to all the coordinates and then make them negative. But as you can see, that's kind of tricky. If you are comfortable doing that, go ahead. So again, you're going to be dividing all the y coordinates by 2 and then making them negative. This one you're going to be... So what does this tell you to do? It says to add 1 to all the x values. So we're going to do the opposite. We're going to minus 1 from the x values and then make them negative. If you want to do that, you can. But I'm going to explain this in another way as well. Granted, it's a 4-mark question. So you can do quite a few steps on this. But there is a shortcut, but it is messy. So what would I do personally? Well, I would try and find the graph of f of x first. Right? Just do it backwards. So what do we do? Well, they times all the y values by 2, so I'm going to divide all the y values by 2. They added 1 to all of the x values, so I'm going to subtract 1 from all the x values. We're going to do the exact opposite. Remember, the 2f of x will double the y values, so these y values are already doubled. I want to then undo that by dividing by 2. This x minus 1 means that they added 1 to x, so I'm going to do the opposite of that and subtract 1 from all of them. Let's draw, we can draw it in blue, why not? So if I take some key points, I would say the key points are probably this one, this one. So I want 3 points, right, because we have 2 straight lines, and each straight line needs 2 points by itself, but since they join at a point, I can actually make that 3 points. But anyways, go ahead. We have 5 and 6, so if we divide y by 2, we get 3. Actually, no, I'm going to write out the coordinates, just make it super clear to everyone. So remember, we divide y by 2, so that makes it 3, and we're going to subtract 1 from x, that's 4. So our new coordinate is 4, 3, which is right here. The next coordinate I picked was 0, minus 4. 0, minus 4. Again, we're going to divide y by 2, so that's minus 2. And we're going to subtract 1 from x, which is minus 1. And look at how I'm doing it, by the way. I do each coordinate separately. Some students try and do both in their head. And why do you need to? Right, just leave a blank space for it and just do it one by one. It's, in my opinion, a lot smarter that way. And then the last coordinate I picked was the one right at the... Ooh, I shouldn't have picked the one at the end, should I? Do you reckon that's going to be 12? It's like half a box. Let's instead pick this one. I should have checked that a bit clearer. So that is 10, 0. So again, we're going to half y, which makes it 0 still. And then we're going to minus 1 from x, so it's 9. And then all we're going to do is join these with straight lines, okay? Again, bear with me because I'm not... Boom. Boom. And if you want, you can then continue these on. This should... There we are, look at that. I love technology. There we go. And then if you want to make it really clear, you can get rid of these points that we used. And now look at that. Gorgeous. That's what the graph originally looked like. That would get you method marks. But again, if you just get the right answer, they give you 4 marks on this. Now we need to do this part here. Minus f of minus x. By the way, just before we go on, in the mark scheme for this, there isn't really a mark scheme. Instead, it's someone's written solutions. They said that stretch is not in the GCSE syllabus. I don't know what they mean by that. This is all in the syllabus still. Okay, you still need to be able to stretch graphs and things like that. I'm pretty sure they mean enlargement, but it is. So, anyways, ignoring that. Minus f of minus x, what does it do? Well, literally all it does is it makes the y values swap sign and the x values swap sign. So what does it actually mean? Well, technically speaking, we're timesing y by -1. So if it's positive, it becomes negative. If it's negative, it becomes positive. And here we're dividing x by -1. Yet again, if it's positive, it becomes negative. Negative becomes positive. It's the same thing. So what I would do is probably still pick the same 3 coordinates. So we have -1, -2. So instead of -1, -2, that's going to become 1, 2. And this coordinate was 4, 3. That's going to become -4, -3. And lastly, but certainly not least, we have 9, 0 is going to become -9, -0. No, I'm joking. -9 and 0. So now we just plot these points. 1, 2. -4, -3. And -9, 0. Yeah, ooh, okay. So if you notice, it's going to be a reflection in the y-axis, and then a reflection in the x-axis. So it's going to be swapped to this side, then it's going to be flipped upside down. So that's fun. But again, you're just joining the dots. You don't need to really think for this question, which is nice. If it was a curve, you'd have to think a lot more, but maybe they're just being nice, which, you know, exams sometimes do. I'm so glad I can just stretch it like this. It's so easy. Look at that. So it's the same graph, just flipped. And that's it for 4 marks. So I would recommend undoing it first, just because it makes your life easier. When you get 4 minutes, you may as well use at least 2 of them. Trying to jump, you might make a mistake. What do you get marks for? You get marks for the points being correct, and you get marks for the shape of the graph. So if you changed it to a curve for whatever reason, you would lose marks for that. Well, this question's fun. Using algebra, show that part of the line is a diameter of the circle with equation x squared plus y squared is 25. Now, this is a 6 marker, and I can see why. So, showing that something's the diameter of the circle, this is actually a pretty good A-level question, to be honest. But you can do it with GCSE knowledge. So, what we need to do is think about what the hell a diameter is. That may sound strange, but what I'm going to do is I'm going to sketch out a nice little diagram. And I'd recommend, whenever you're stuck in maths, drawing a diagram, because don't forget, everything you do in maths, it does represent something. It's not just nonsense. I'm going to draw a pretty big circle. Alright. Really? Alright, fine. Imagine that's a... Wait, can I? Ah, there we are. Okay. There we go. We've got like a circle-ish, right? Now, don't forget, circles are always based around the origin in GCSE, which is pretty good. And what is a diameter? Well, a diameter is going to be a line that passes through the center of the circle. The center of the circle. Like that. And yeah, it's going to go the full width of the circle. So how can we prove that? Well, if you remember this equation here, this x squared plus y squared is 25. This part is actually the radius squared. So the radius is equal to the square root of 25, which is 5. Which means the diameter should equal 10. Right? So it should be 5 from here to here and 5 from here to here. So what I could do is work out the point of intersection between the line and the circle. Now, how do I know they intersect? Well, since it says show that the line is the diameter of the circle, it must mean that the line is the diameter of the circle. They can't ask you to show something that isn't true. Right? If I said show that 4 is a prime number, that's an unfair question because it isn't a prime number. So, I know for a fact that this line and this point intersect, but not just that, that the line is the diameter of the circle. So, let's find the coordinates and then try and show that its length is 10. And that will prove to me that it's a diameter. So, how do I want to do this? Well, you want to rearrange for x or y in this equation and then shove it into here. Let's rearrange for y, why not? So we have 3x like that. There you go. And now shove it into the equation of the circle. which would be x squared plus negative 3 over 4 squared, x squared, geez, equals 25. Let's expand that. In fact, I'm going to be super lazy and just use a calculator. So we have, there we go, we have 1 plus minus 3 over 4 squared. That's how many x squareds we have. So 25 over 16 x squared equals 25. I can cancel the 25 from both sides, make them both 1s, which means x squared equals 16, which means x is equal to plus minus 4. Now, why is it plus minus 4? Well, have a think. We've solved for the points of intersection of this line and this circle. They intersect at 2 points, so there should be 2 coordinates, okay? So we need to find both sets of coordinates. We have x is equal to, let's say, negative 4 over here and 4 over here. And what we're going to do is we're going to substitute into this equation here to find the y coordinates. So when x is minus 4, we have y equals negative 3 over 4 times 4. So in other words, we have y is equal to 3. Yeah? So my first coordinate is minus 4, 3, which is going to be on this side, right? That doesn't really matter that much, but anyways. And then 4, okay, I can kind of tell what y is going to be when x is 4, because it's minus 3 over 4 of 4 again, so it's just minus 3. So it looks like I picked 2 points which are actually pretty reasonable, which is funny. Which is 4, negative 3. Cool. Straight line through the origin. Now, I've drawn it through the origin, but do we need to prove that? Well, you can prove it if you want. And simply put, I've actually already done it. If you look at this equation, what's the y-intercept? The y-intercept is 0, so it does pass through the origin. So that line is completely fine. So, how can I prove that this is the diameter? Well, what we're going to do is work out the length of the line. Now, some people like to memorize the equation where it's the square root of y2 minus y1 squared plus x2 minus x1 squared. That's long. Instead, that is just the equation for Pythagoras. So what I like to do is I like to work out the width of the triangle. Well, it goes from minus 4 to 4, so that width is 8. And it goes from 3 to minus 3, so that width is 6. That to me makes a lot more sense. But, of course, it's up to you. Let's keep going. Yep. So we have 8 squared plus 16 squared, and then square rooted. So let's call it the length, sure, is 8 squared plus, did I say 16 squared? It should be 6 squared. Goodness gracious. Which is the square root of 64 plus 36, which is the square root of 100, which is 10, which is equal to the diameter. So it is equal to the diameter and it passes through the origin. That's it. Right? Prove it's the diameter? Well, it's the same length that the diameter should be, and it passes through the origin. It has to be a diameter. And keep in mind that even just finding the length would prove it's a diameter. Because, again, if it was a different length, then of course it's not the diameter because it's going through a weird point. But it intersects the 2 points. The length of those 2 points, between those 2 points, is the diameter, and it goes through the origin. It's definitely 100% a diameter. Sue is making a toy rocket in her science lesson, which is to be launched from the ground. The flight path is modelled by a quadratic. H is the height in meters, T is the time in seconds. Find the maximum height above the ground and the time it takes. 4 by marks. Really? That's generous. So why? Well, a lot of students get lost in the context. So they think, how am I meant to work out height? Oh my god, is it a physics lesson? Like, they get a bit worked up. What they're asking you to do is find the maximum of that equation. And what type of equation is this? What type of equation is this? It is a quadratic. And how do you work out the maximum or minimum of a quadratic? Well, the only way you guys should know is completing the square, because that gives you the turning point, which can be a maximum or minimum. So all they're asking you to do is do completing the square. That's it. That's what I'm saying. The marks are pretty generous. Now, it's not the easiest thing in the world to do. So just the general equation for completing the square, it's x squared plus bx plus c. Then you'll have x plus b over 2 squared minus b over 2 squared and then plus c. But if you notice, there is nothing in front of the x squared because the number in front of x squared has to be 1. So what we're going to do is I'm going to factorize out negative 2 just from the first two terms. So that makes that negative 2 t squared minus 3t, and then outside the brackets we have a plus 1. Because remember, I didn't factorize it from everything. Now we do completing the square. Negative 2, I'm going to make it a big bracket, t minus 3 over 2 squared minus 3 over 2 squared plus 1. Then keep going. I'm going to skip a line just because it's getting a bit messy. Do I want to expand the bracket? Am I being a bit juicy? I'm being a bit juicy. No, it's fine. Let's do it this way. T minus 3 over 2 squared. That would be 9 over 4, be negative 9 over 4. Expand the brackets again. Again, I'm doing it every other line now just because I don't want to make it too cramped. Again, believe it or not, one of the biggest causes of lost marks in certain years was actually handwriting. So because examiners couldn't read it, they couldn't do anything. That would become plus 9 over 2. Again, just do negative 2 times minus 9 over 4 if you don't believe me. And it's still the plus 1 on the end. So we could let's just work it out. Minus 2 t minus 3 over 2 squared. So that would be 2 over 2, 11 over 2. Yeah. 11 over 2. And that is for the height, h. So now we're working out the maximum of this equation. Well, if you remember how to work out the maximum, all you do is you flip the sign of this, and that's your x value. And you keep this exactly the same, 11 over 2. The reason for that is if you think about what's the biggest thing this equation could become, well, the biggest thing this could become is 0. Why? Because if I make this thing in here positive, then it's going to be times by minus, which makes it smaller. And if and don't forget we're looking at the maximum value, right? So we're trying to make it as big as possible. And if I make this negative, it gets squared and becomes positive, in which case I times it by a negative again. So that's not good. So the biggest thing this can be is 0. So that's why. Now, we don't have x and y, instead we have h and t. So we're trying to look for the maximum height and the time it takes. Well, t is our x value and h is our y value. So what is the maximum height? The maximum height is 11 over 2 meters. It is in meters, right? Yeah. And t is seconds. Actually, no, I'm not even going to write at. I'm going to say after 3 over 2 seconds, like that. Because that's what it says, right? The height above and the time it takes to reach it. So it reaches the maximum height of 11 over 2 after 3 over 2 seconds. 5 marks. It's pretty good. It's not bad, but again, it's applying it in context, which a lot of students find difficult, but it's just a quadratic. So treat it like a quadratic. So with this question, we have that shape A is a regular polygon. Now, again, the second I read the word regular, it means that all angles are the same, as well as all sides. So we should also write all sides the same as well. That's going to help us in this question probably, because they wouldn't mention it otherwise. The ratio of the size of the interior to exterior angle is 7 to 2. The ratio of the side length to the number of sides is 5 to 3. Find the perimeter. Now finding the perimeter is pretty interesting because remember, because it's regular, all the sides are the same. So if I work out the length of one side and I know how many sides there are, I can just multiply them together. So I need two things. The number of sides and the length of one side. That's what I'm thinking. Now maybe there is a different solution. Maybe I won't need that, but that is my initial goal. That's what I'm aiming for now. And if I look at the first piece of information, the ratio of the interior to exterior angles is 7 to 2. Number of sides is pretty interesting because I'm thinking of using the interior angles or the exterior angles. So for example, the exterior angle of a regular polygon is just 360 divided by the number of sides. So if I know what the exterior angle is using this ratio, then I can use that equation. So let me think. Well, first of all, This is some very niche, ambiguous bit of geometry, but the interior plus exterior angle should always add up to 180 degrees. Always. Now, this should make some amount of sense, right? Like if I have, let's say I have a, God, I'm going to try and draw a pentagon. Cool. The exterior angle will be that, the interior will be this. That just makes a straight line. So essentially this is just angles on a straight line add up to 180. So that is a fact, but it isn't one that is very often used. Now I know that there is a ratio of 7 to 2, so I'm going to call it interior to exterior is 7 to 2. So in total there's 9 parts. So we're taking 180 degrees, because that's what they should add up to, and breaking it up into 9 different parts. So one part would equal then 180 divided by 9 would give me 20 degrees, which means the exterior angle is equal to 2 times 20, which is 40 degrees. And remember that equation I mentioned. So the exterior angle of any polygon is just 360 divided by the number of sides. So I know that this is 40, so 40 equals 360 over n. So 40n equals 360. So n is equal to 360 over 40, which is, so knock off the zeros, 36 divided by 4, 9-sided shape. So I've got the first piece of information that I needed. I've got the number of sides. Now the length of one side is interesting. However, it just says the ratio of the side length to the number is 5 to 3. So length to number is 5 to 3. Now I know that this is a 9-sided shape. So if I write this as a ratio, the right hand side should equal 9. So it's obviously been simplified because the number of sides is not 3, it's 9. So how do I go from 3 to 9? I multiply by 3. So how do I go from 5 to whatever this is? I multiply by 3. 15 to 9. So in other words, each side is 15. I mean, it doesn't actually give us a length in terms of like centimeters or anything. So I can't give it a unit. I could say just units, but that means one side is going to be 15 units long, which means the perimeter is the number of sides, 9, times the length of one side, which is 15. The reason for this is the length is going to be 9 times bigger than the length of one side. Okay, so if you'd like, if you were to rearrange this, you can make it 15 over 9 to 1. So in other words, one side is that long. So then you can work it out. Perfect. 9 times 15, 135 units long. And that should be it for your answer. So Jamal is going to paddle between 3 points on a large lake. He will start on point A and paddle on a bearing of 50 degrees until he reaches B. Once at B, he will then paddle 1.6 kilometers to reach C, and there's the bearing. He'll then paddle directly back. We will finish. The bearing of C from A is 98 degrees. Okay, given that Jamal can paddle at an average speed of 7.2 kp. Okay, this should be kilometers per hour. Maybe kph is fine. Normally, yeah, okay, anyways. Find the time it would take for him to pedal. Okay, this is one of those questions where you look at it and you think, what the hell do I do? So, take a second. They've given me speed and we want time. And if you remember, speed is equal to distance over time. So, time is equal to distance over speed. I have speed already, so the only thing I need is to work out the distance he travels. Okay. Now they've given me some distances already. They give me 1.6 kilometers and that's it. Yes, that's all they've given me. So they've given me one distance, but if you notice, since he paddles between 3 points, it's actually a triangle he's making. So we need to work out basically the perimeter of the triangle and then do that. So let's start drawing out our diagram. So, okay, let's just start. I'm going to say point A is here. I have no proof of that. I'm just going to say 50 degrees bearing. Well, if you remember rightly, it's always at an angle from north. So 50 degrees would be something like that. And he goes, well, we don't know how long he goes for, do we? So let's just say point B is up here. I want to make my diagram nice and big. That right there is 50 degrees. Once upon B, he would travel a bearing of 142. Okay, so 180 would be straight down. Going to the right would be 90. So it'd be kind of like a diagonal like this, right? And that right there is whatever this angle is. 142 degrees. And then he travels straight back. Cool. It's not a bad triangle. It also tells me that's 1.6 kilometers. It's a massive lake he's on. The bearing of C from A is 98. Ah, of C from A. Okay. So that means this angle is 98 degrees. This is good. Okay, this is really good. This is really good. So I know that this interior angle here is 98, right? The full thing minus 50. So that's actually 48 degrees. Beautiful. And let's see, what else could we do? Okay, there's another thing we can work out. I'm going to move point B, I'm going to move it up here. I can actually work out this angle here now. Now you might be thinking, how the hell can you do that? Well, I can work out this angle here. Now you might be thinking, how the hell can you do that? Well, if you notice, these north lines are always parallel to each other, right? Of course they are. So this is like a big C shape. I can use co-interior angles add up to 180. So 180 minus 50 gives me this angle, which is 130 degrees, which means the angle on the inside, you know what, I should have made that red to make it super clear. 130, because again, angles, co-interior angles add up to 180, which means this angle here is going to be, well, what I'm going to do is I'm going to add together 142 and 130, and I'm going to do 360 minus that. That's going to give me 88. That's the inside bit, because remember, angles around a point add up to 360. It was 88 degrees. Angles on a point add up to 360 degrees. Let me just double check that. I closed the... Oh, there we are. Okay, cool. Okay, this is looking... Okay, so we just need to work out the other two sides. I've realized we can use sine rule. We have an angle and its opposite side. We have another angle, so we can work out the opposite side. That's perfect. That's a dream. So if I call that side AC over sine 88 equals 1.6 over sine 48. Remember that there's two versions of the sine rule. You can rearrange it, but you can always do the sides over the angles, or you can do the angles over the sides. Both of them work out pretty nicely. Also, we can actually work out this angle here, because angles in a triangle add up to 180. So before we do that, I'm going to do that because we need to use sine rule again to work out the side length here. So I may as well just do this. So 88 plus 48, and then do 180 minus answer gives me 44 degrees. So I know that that final angle here is 44 degrees. And then that means AC is just going to equal 1.6 over sine 48 times sine 88. Not gonna lie, this paper so far is probably one of the trickiest ones that I've done. So that's fun. And then we can just use our calculators to work out this value. But yeah, it's definitely one of the harder papers. 1.6 over sine 48. There we are. Multiplied by sine 88. We don't need to use brackets in this case because the actual order doesn't really matter to an extent. We get I'm going to call it 15 kilometers. It says answer to our nearest minute. Okay, we're going to round it to 2.15, keep it to 3SF until the very end. 2.15 kilometers. And again, so just to fill that in, that's this distance here. So the last distance, technically you can use cosine rule, you can use sine rule, you can use whatever rule you want really. This is complete freedom. Yeah, I mean, we kind of need to, right? There's no... Just double checking. Yeah, they didn't give us any other value, so we have to work out what A to be. Hang on. Oh. I misread the question. Find the time it will take him to paddle directly back to point A from point C. So all I needed was this distance. Cool. So all I actually just need to do is speed equals distance over time. Now, yeah, this will be fine. So time is equal to distance over speed. So that equals 2.15 over 7.2. Now, of course, this is in kilometers per hour, so my answer is actually going to be in per hours. So I'm going to take this value, answer, divide it by 7.2. That gives me the number of hours it takes. 0.298 ... hours. So then to get minutes, you just multiply by 60. And it says to the nearest minutes, I'm just going to round it, 18 minutes to get back. 18 minutes, and that's it. How many marks was that? 6 marks! Really? Alright, I guess there is quite a few things to work out, like we had to work out these angles here, 48 and 88. So I guess that was a bit tricky. But yeah, that's pretty generous. That's not bad. If you knew what to do, that's quite smooth, as in you don't have to write that much, just knowing what to do, which is tricky. Okay, so for this one, a lovely little proof. Triangle ABC is an isosceles triangle. AB equals BC. The points lie on AC such that we have these... I'm not even going to bother looking at that really first. Prove that... Okay, so we need to draw a diagram because I don't even know what they're talking about in terms of triangles. So let's draw the ABC triangle first. So I'm going to draw one that looks... This is going to look like an equilateral triangle, but just take my word for it, it's not. And that means that is ABC, so let's call it A, B, C. And because it's isosceles, it means these two sides are identical. Now, what is it talking about here? So we have AY, I'm going to write this in black. AY is equal to 3AX. Points X and Y lie on this thing, okay? And AC is equal to 4AX. Okie dokie. So, what I'm reading here is that the full length AC is 4 times AX. So let's put X, let's say, here. And A to Y is 3AX. So it's 3 units along. So let's say it's around here. As Y. So in other words, what they've done is they've split this into 4 equal pieces, right? So that's 1 piece. This is 2 pieces. That's 1 piece there. Hopefully you can see that. Because don't forget the middle is actually a bit bigger. I've just drawn it a bit wonky. This is not an accurate diagram, it's a sketch. So again, just to reiterate, AC is 4 times AX, which means AX is a quarter of AC. Now because AY is 3 times that, it means that it's going to be 1, 2, 3 quarters of the way along. So split up as a 1, 2, 1 triangle. And then if we finish off what this triangle looks like, oh, come on, autocorrect, please. Fine, don't autocorrect. Instead, it looks like a stick man's legs. Imagine they're straight lines anyway. And we need to prove that ABX and CBY, so basically, these two triangles are congruent, which means they are the same. So we're looking at like side, angle, angle, all of that kind of fun stuff. So what's the first thing I can notice? Well, the first thing I notice is, of course, AX and CY are the same. Right? And the reason for that is they're both a quarter of AC. So that's one. They've got a side in common. The next thing I notice, of course, AB is equal to BC. Because, again, it's an isosceles triangle. So far I've got SS. So the one I'm thinking of is side, angle, side. So we have that these sides here are the same. So can we prove that the angle that is between those two sides, so let me rephrase that. We have this side and this side are the same on both sides of the triangle. If we can prove that the green angle is the same, then that means it's side, angle, side. Remember, the angle in SAS is the angle between the two sides that are identical. So this side is identical, this side is identical. That means that green angle should be, well, if we can prove it's identical, then that's it. Well, good news. ABC is an isosceles triangle. And what's important about isosceles triangle? Well, these two sides are the same. The base angles are equal. So again, we know that. Oh God, what am I scrolling about for? Okay. So we know that angle BAC equals BCA because base angles of isosceles triangle, I'm just going to write of isosceles, are equal. So in other words, they are congruent because SAS. The sides and the angle between them on both of these triangles is the same. Therefore, they are congruent. That bags us a nice tidy 3 marks. By the way, I want to point this out before we go. They've asked questions very similar to this multiple times. They may change these numbers, but the actual process is actually the same. So if they ever mention an isosceles triangle, they make another one, it's the same process, okay? Just a tip. By the way, literally just my first thoughts. This shape, or if you flip it upside down, has come up in so many past papers. It's like an ice cream, right? If you think about it, like this is the cone and that's the actual ice cream. Or if you flip it upside down, it definitely is an ice cream cone. They've asked about these shapes so many times. And I'm not going to lie to you, normally they give you the formulas. So I'm actually going to give you the formulas. Yeah, there's no real need to it. So the sphere at the bottom is 4/3 pi r cubed. And the volume of a cone is 1/3 pi r squared h. Yeah, I don't know why they didn't give you it in this question because I think this is kind of an old spec question, to be honest. Not that it can't come up because this came up in the 2019 paper, I want to say. Something like that. Not this exact question, but this exact shape. But they gave you the actual formulas. Company T, very creative, are designing a toy to be sold online. It'll be made up of a hemisphere, cool, and a right cone, yeah, or just cone, be attached. Given that the total mass is 100 pi and the density is 60 grams over per cubic centimeter, express y in terms of x. Okay. 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 Here's what we need to do. It has like given that. So what we want to do is work out the volume of this shape. That's the first thing. And what we're going to do is then be able to rearrange it all in terms of x and y. And we want to get an equation that looks like y equals and then blah, blah, blah with some kind of x in there. Could be on the bottom, could be on the top, whatever. And there's a reason why they've given us the mass and the density. But let's take it one step at a time. The volume of this shape is going to be the volume of the cone. Okay, that's nice and easy. 1/3 pi. What's r in this case? R is x. In fact, I'm going to use the curly x times h, which is y. Then we're adding the volume of a hemisphere. Now, they give you the volume of sphere in the exam, in the questions, so don't forget to half it. To half it, you can either make it 4/6 or 2/3. I prefer the 2/3 because small numbers make me happy. And that is x cubed. Why am I putting brackets? See, that's actually good practice, I'm using brackets, but since it's not a number, there's not really any point. And that's pretty much all we can write. So, I can't rearrange that for y equals something to do with x because we have a big V here. And that's not really useful. So, let's use the other information they gave us. The total mass is 100 pi and the density is this. So if we think about the density equation, it's mass over volume. So in other words, volume should equal mass over density. So what we can do is we can take the mass divided by density. So we can do 100 pi over 60 equals this entire thing that we just made. And now we definitely can rearrange it for y. It's just going to take a bit of algebra, but that's all good, right? Yeah, that's fine. Who cares, right? I'm actually going to cancel out the pi straight away because we can divide everything by pi. How do I want to rearrange this? I want to move everything that isn't y onto the other side. So I want to minus 2/3 x cubed. So 100 over 60 would simplify to what? 5? Yeah, 5 over 3. Right. 5 over 3 minus 2 over 3 x cubed. Okay, I know what I can do. 1/3 x squared y. I'm going to times through by 3. So if I times everything by 3, hopefully you can see that all of these fractions actually disappear. Cubed x squared y. Divide both sides by x squared, I'm done. So we get 5 over x squared minus 2x equals y. That is its simplest form. That is it. Okay. 6 marks! I guess so. Not bad. I will say that these questions always answer quite badly. Even though the actual level of knowledge is quite rudimentary. I'm not saying it's easy, but the amount of skill you need, okay, that's a bad thing. The skills you need to know or be aware of aren't that complicated, right? Like volumes of compound shapes, you do that in year 7 and 8. The algebra is the hard bit, and also knowing to equate it to this. So again, I'm not trying to insult you. But anyways. There are n boys in a class at school. For every 2 boys in the class, there are 3 girls. 3 students are chosen at random and are taken out of the class. Given that the probability of choosing 3 boys is 1 over 30, show that this quadratic expression. This is actually a fairly common type of question nowadays in terms of calling it. It's sometimes called like quadratic probability, things like that, where they give you essentially this information. You have to make a quadratic out of it, and sometimes you have to solve it. So this should be 5 marks, and then solving it would give you the 6th mark, because there'd be one value of n for which this is true. So it tells me there are n boys in a class at school. Now, when I do probability, if I'm picking like a boy, I need the number of boys, right, over the number of like people, right? So the number of boys, that's fine. I can just call that n because it tells me there are n boys. But the number of people, I need to work out some expression for. Now, if I look at the answer, there's only n here. So I'm thinking that I want to get the number of people in terms of n. So going back to this, we have a ratio of boys to girls. So B to G of 2 to 3, right? Which is 5 parts in total if you care. Now, the boys represent n, right? So what we could do is, doing some movie magic, we could basically write an expression for the girls in terms of the boys. So the boys are worth 2 parts. So it means the girls are worth 3 parts. So how much n would they be? Well, to go from here to here, you times by 1.5. So that would actually be 3 over 2n, right? Where 3 over 2 is 1.5. I hope that makes sense. So that's the number of girls. So if boys is equal to n, and we need b plus g. So we have boys, which is n, plus 3 over 2n, which gives me 5 over 2n. That is the total number of people. So the probability of getting 3 boys. So to get 1 boy, you would need n over 5 over 2n. Then we're going to times it by, where we take 1 away from the top and 1 away from the bottom, times n minus 2 over 5 over 2 n minus 2. And that should give me an answer of 130, 1 over 30. I can cancel out the n's from this side. And now it's just a lot of rearranging. Yay. So this first thing is now, because it's like 1 over, it's going to be 2 over 5 instead of 5 over 2. The reason for this is if you put in your calculator, so that now becomes 1 over 5 over 2. Well, if you put that in your calculator, you get 2 over 5. It just takes the reciprocal. And I'm actually going to times these two together straight away because there's no point in waiting for this. We're going to get n minus 1, n minus 2 over 5 over 2, n minus 1, 5 over 2, n minus 2. Now, technically, if you wanted to, you could like times the top and bottom to get rid of the fraction. It's not really worth it. Let's just keep it as a fraction. Actually, what I'm going to do here is I'm going to divide both sides by 5/2 so I can actually get rid of that, and then I'm going to expand the brackets. So the right-hand side is going to be 1/30 divided by 2/5, which gives me a 12th. Perfect. Because we don't need that. Top of the fraction is going to be n squared minus 3n plus 2. The bottom, it'd be 5/2 times 5/2, which is 25/4n squared. Then we would have, okay, this is going to be a bit tricky. We're going to have minus, so 5/2n times minus 2 is minus 5n. Then we're going to have minus 5/2n again. Then minus 1 times minus 2 is plus 2. And we need to simplify that. Okay, I'm trying to like what am I trying to say? I was trying to skip some steps to make it a bit faster, but let's just take it nice and slow because there's no point in trying to skip steps, especially when you're trying to explain something. Hopefully so far this makes sense. That's still going to equal 25/4n squared. Minus 5 minus 5/2, so that'd be minus 5 minus 2.5. That's minus 7.5n, which is 15/2. Plus 2 equals 1/12. I'm going to cross multiply. So I'm going to move the 12 up to this side. I'll move this over to this side. That gives me 12 times n squared minus 3n plus 2 equals 25/4 n squared minus 15/2n plus 2. Expand the brackets, you know the drill. It's 24. We're going to have to times through by 4 to get rid of the fractions as well. Because in our answer, if you notice, we don't have any fractions. So I'm going to times through by 4. And we have to do that to both sides, so that's 48n squared. Minus 144n plus 96 equals 25n squared minus 30n. You can check this all on a calculator if you want. Move everything to the left hand side and we do indeed get that. So 48n squared minus 25n squared is going to give me 23n squared as shown in the answer. Minus 144n and we have to plus 30n. So it's minus 114n. Then minus 8 from both sides gives me plus 88 equals 0, which is the correct answer. So yeah, and that is a standard question. There's even a section on Maths Genie all about those types of questions. Hopefully it makes sense. And yeah, that's 5 marks. Not many marks for a hell of a lot of algebra, to be honest, but it is what it is. Diagram below shows 2 lines, line L1 and line 2. And it tells us a bit of information about both of those lines. So I can see that this is line 1 because it has a positive gradient, and this must be line 2. And they intersect at the point A, which is PQ, so we may as well add that to our diagram. And L2 crosses the line, crosses the y-axis. At the point B, we need to show that the coordinates are 0, which obviously makes sense, it's a y-intercept. And then P over 2 plus Q. Okay. So how do we find y-intercepts normally, right? Because that's what B is, it's a y-intercept. What we do is we find the equation of the line and the C term, because we have y equals mx plus c. The C term is the y-intercept. So, okay, we need to find the equation for line 2 then. So if we look at line 2, y equals mx plus c, is there anything that we know immediately? Well, it tells me that the line L1 has a gradient of 2, and it also tells me that line 2 is perpendicular to line 1, which means that its gradient is the negative reciprocal. So instead of 2, it's going to be 1/2, and then instead of positive, it's going to be negative. So we have, straight away, y is equal to negative ½ x plus c. Now, if we look at the answer, we don't get a number, right? We get some letters. And if you notice, the letters are the coordinates of point A, because how do we normally find the y-intercept after we have the gradient? All we do is we substitute in our x and y values. So that's what I'm going to do. X is equal to P, y is equal to Q. That is a Q, believe me. So we get Q is equal to negative a half P plus C. So that means C is equal to, so add the minus half to the other side, we get Q. Actually, let's write it in the way that they want it. So instead of minus a half P, it's going to be positive a half P. So that's the same as writing P over 2. And then plus Q. So that means the coordinates of B are, of course, 0. And as they said, P over 2 plus Q. Just like that. Nothing too fancy there. But again, it is a bit tricky when you have to use a bunch of algebra and interpret the question. So hopefully the way I explained it makes a bit more sense. I'm talking my thought process through. This is an interesting question. And the reason why I say that is because I already see two different trig graphs. So the graphs of y equals 2 cos x and sine x as shown in the diagram below. Now, some people are not that great at knowing what the graphs look like, but if you notice, sine and cos always go between 1 and negative 1. So with the 2 cos x, that means it's going to go between 2 and minus 2. So I know that this is the cos x graph and this is the sine x graph just from looking at the maximum values. I don't even actually need to know much about what they are. And it says use the graphs to find estimates for the solutions of the equation sine x minus 2 cos x equals 0. Show you're working. Okay. So if I quickly rearrange that, that is sine x equals 2 cos x. So in other words, I'm looking for the points of intersection of this graph, which are here and here. And all I'm doing is I'm trying to, and bear in mind that this is an estimate, okay? It's not going to be an exact value because you can't. You don't have the ability to do that just yet. So we're just going to look at these, and how do we find the exact value? Well, what I would do is I'll just mark values on the graph that I do know. So what values do I know? Well, I know that every 90 degrees on a sine or a cos graph, something interesting happens. So what do I mean by that? Well, it either goes from its maximum to 0, 0 to its minimum, or minimum to 0. Basically, every time the value changes to a value you know, it's going to add another 90 degrees. And here is the last one, that would be 270. And the very last one over here is 360. So again, these are estimates. So realistically, you do have quite a bit of leeway. If I look here, it is close to 90, but it's not quite. So if we say that this would be around 45, then this should be around 60. So x is approximately 60 degrees, and x equals, let's find the next value, somewhere over here. So it's between 180 and 270, but it's closer to 270. So maybe 220, 230? Maybe even 240. Let's just say 240. Now, I actually know how to check my answer because I do know how to work out this stuff, but that's A-level maths, so don't worry. This is perfectly fine. 4 marks. In terms of like the range of values, I would argue it is between 55 to 65 and 230 to 235 to 245. I'd argue those are the range that you get, about 10 degrees, which is a bit harsh, I will admit. It really depends on how well you know the sine and cos graphs. I know them really, really well, so that's how I can come up with those kinds of values. But yeah, keep that in mind. The diagram below shows the graph of an equation for a circle, x squared plus y squared is 8, and part of the graph with y equals 1 over x squared plus 1. And the points A, which is P and Q, so let's fill this on the graph again, just so we can really visualize what's happening, and B, R, and S are two of the points where the graphs intersect. Using the graph above, find the solutions to the simultaneous equations. Okay, so you may or may not know that, as you can see, the two equations we're trying to find the solutions of are the two equations that they've drawn on a graph for us. That is by design, because it isn't, you know, they don't expect you to be able to like draw this out all by yourself. That's kind of a waste of time. But the solutions are just going to be the coordinates of the points where they intersect. So two of our solutions already is x equals p, x equals r, y equals q, y equals x. Sorry. Yeah. So for part A, we have an x equals p, we have y equals q. So we are going to get quite a few different answers. X equals, what is it, r and s? Yeah, x equals r, and y equals s. Okay, those are two solutions that we have so far. Two for each x and y. However, we also need to work out the points of this intersection and this intersection as well. Now, this isn't as hard as you may think. You might be able to count the boxes and all this other kind of stuff just to verify what I'm about to say. But can you see that the distance between these points, so between the points and the line, it goes about 1.5 boxes in and then 1.5 boxes out. In other words, this graph, both of these graphs, are symmetrical about the y-axis. Everything on the left-hand side is a mirror image of the stuff that's on the right-hand side, which again makes sense. You can count the boxes, right? This point is 1.5 boxes from the y-axis. This point is 1.5 boxes from the y-axis. Same thing over here. That's a certain number of boxes. That's a certain number of boxes too. So what does this mean? It means that the y values are going to be exactly the same, of course. So I can fill in those y values straight away. And something, comma s. But what does it mean about the x values? Well, because they're symmetrical, they're a mirror image, it means the x coordinate is the same, but with the opposite sign. And again, that's because I'm going 1.5 boxes to get to A, I'm going 1.5 boxes to get to this point. It's the same distance, which means they should have the same x coordinate, just the opposite sign. So we're actually done already. The other set of solutions is x equals minus p, y equals q, x equals minus r, y equals s. That's it, because they're symmetrical. So now it says part B. Looks a bit more interesting. And it does say give you your answer in terms of P, Q, R, and S. So we are done. We don't have to do anything else. There are two real solutions to the simultaneous equation x squared plus y squared equals 8 and x equals a. Find the set of values for A. Find the set of values of A, giving your answer in simplified surd form. Interesting. So what we need to do is try and figure out what's going on here. So this is a bit interesting. I've spotted what they need us to do. Let's blank out all this for a second. If I ask you to draw a line of x equals a, you would hopefully draw a vertically upwards. That doesn't make sense. A vertical line at some point on this graph, right? So maybe it's straight down from here. Maybe it's straight down over here. Maybe it's straight down over here, right? And the problem is we don't actually know, because it just says x equals a, and a could be any value. We don't actually know whereabouts it is, but they do give us some information. There are two real solutions. This means it intersects twice. So why is that interesting? Well, I know it can't be outside the circle, because then it won't intersect ever. So it can't be anywhere along here, and it also can't be anywhere along here. It also can't just touch the circle like that, because then it would only have one solution. So it also can't be here. In other words, this line has to be at some point inside the circle, anywhere along here. Now that's why it says find the set of values, because we're not going to get x equals this. We're going to get a range of values. So the question is, how do I describe this range? Well, I need to work out what these 2 points are. Now that might sound scary, but it's actually not that bad. If we look over here, this is the radius squared of the circle, which means the actual radius is square root 8. The distance from the center to the edge. So this coordinate is root 8, 0. Because it's root 8 away from the center, 0. This point is minus root 8, 0. Because it's root 8 in the other direction. So in other words, my set of solutions for A are between minus root 8 and positive root 8. Now here's the real key thing. You might wonder, why did I not put the equal sign? Well, if you remember what I said, it can't equal root 8 because then it would only have one point of intersection, which would be at minus root 8 or plus root 8. So that does not work. Instead, it has to be between those values, not including those values. So I hope that makes a bit more sense about where that comes from. But that would be what you want to do. It does say give it in simplified third form, so you have to simplify it. So that would be, so root 8 is root 4, root 2. By the way, you could just use a calculator for this. I don't know why I'm doing it the long way. I'm just a bit too lazy to open up my calculator. But it'd be like this. But that's why it's not equals to, because it can't equal this value, because otherwise it would only intersect once, and it says here 2 solutions. So 2 points of intersection. The students in class X and Y sat the same maths exam. The information is given about each, but the performance of each class in the table below. So lowest score, highest score, and all of the quartiles. Perfection. The median score was of X was half the median score of Y. The interquartile range of X was 3 times the interquartile range of Y. Michael scored 17 marks in his maths exam, and we need to fill in the sentence, which is Michael's in the top something percent of performers in class X or Y. Okay, the X or Y thing, this bit is a bit interesting, but this bit, so let's ignore that for now. And again, that's exactly what I'm being completely honest. I'm like, okay, I don't know how we're going to determine X or Y, but since Michael's in the top blank performers, so what we're going to do is work out the range of values that were scored in this maths exam, and then work out what 17 marks is. So in other words, we need to work out what X is and what Y is. So how can we do that? Well, using the information they gave us. The first sentence, let's label this. The median score for X was half the median score for Y. So in other words, class Y has double the median of X. So if we write the median, we have Y minus 1 equals double, because remember, class X was half as big, so in other words, double. So for example, if you have £10 and I have half as much as you, I have £5. So the other way you could say that is you have twice as much as me. That's my first equation. The interquartile range for X is 3 times the interquartile range for Y. So the interquartile range for X would be the difference in the upper and lower quartiles. So 4x plus 2. And by the way, you need to use brackets for this, because it's not just, you know, some people would write this as 3x plus 4. Because what they do is they do 4x plus 2 minus x plus 2. No, you're minusing the whole thing. And that equals 3 times the interquartile range for y. So it means I might want to use a bit of nested brackets here. Upper quartile for y is 3y plus 1. Again, I'm going to use brackets just to make sure my signs all match up. And 2y plus 1. Okay, so minus 2y plus 1, like so. I just realised I didn't write the median for x. X squared minus 3. There we go. So we have 2 equations, 2 unknowns. That smells like simultaneous equations to me. So I'm going to, do I want to expand them yet? Yeah, okay, let's just expand everything. What I'm going to do, I'm going to use up more space than you would have in the exam. I'm just going to put this up. So that would be y squared minus y equals 2x squared minus 6. Then on this side we have 4x minus x, so we have 3x. And then we have 2 minus 2, which is 0. And that equals 3 times 3y minus 2y is just y. 1 minus 2 is minus 1. Okay. Cross off the 3's from both sides. We have x is equal to y minus 1. So now what we're going to do is sub that. Wait, is that how much space they gave me? Are you joking? Alright, this is going to get me interesting. Give me a second. I'm going to create some more space for myself. Okay, I just dragged the other questions down. I just didn't want any spoilers. So, just sub it in and we're going to solve the simultaneous equation that comes out of it. So we're going to sub this into the x part over here. So we have y squared minus y equals 2 y minus 1 squared minus 6. Let's keep going. Y squared minus y equals 2 That'd be y squared minus 2y plus 1 minus 6. Expand the brackets. Y squared minus y equals, yeah, we can, okay. I was trying to find a little shortcut. Minus 4y. Then we have 2 times 1, which is 2, minus 6 would be minus 4. Let's move everything over to the right hand side, so we get 0 equals y squared minus 3y minus 4. And now we're going to solve. And we're going to get 2 answers, but again, I'm always thinking ahead. If I have 2 answers, what am I going to get? But don't worry, don't need to be that far ahead. This will make sense. Equation slash func. Polynomial degree is 2. We have 1, we have negative 3, and we have negative 4. Which gives me an answer of 4. God, not 1. Y equals 4, and y equals, and again, I like to space these out. Whoops. Negative 1. Now, if we think about it, I mean, I know we almost always get rid of the negative, but you do need to think about it because there's no reason why they couldn't give you an unseen question where you get rid of the positive, depending on the context. Maybe it's like a loss margin or something, I don't know. But this is the number of marks. Now, unless you've done really bad, I doubt you got a negative number of marks in your exam. So let's assume they didn't get that. But what we can do is even still take this equation and work out the x values for both, because maybe, just maybe, it gives us a different value. So when y equals 4, x equals 4 minus 1, which is 3. And when y equals minus 1, x equals minus 1 minus 1, which is minus 2. So these two are not applicable because they are negative, and we can't get negative marks in an exam, again, unless you've done something really dodgy. So these are our solutions. Perfect. That is the first part of this question done. Now what we need to do is using these solutions, so I'm going to actually write them up here because I'm incredibly lazy. Was it x equals 3? Yeah. Is just quickly write out all of these answers now. I know, tedious, but we do know it. So 3 minus 1 is 2. 4 plus 1 is 5. That would be 5. This one will be 4 plus 1 is 5. Times 2 is 10. 3 squared is 9. Minus 3 is 6. 4 times 3 is 12. 4 times 3 is 12 plus 2 is 14. 3 times 4 is 12 plus 1 is 13. So we have 9, 11 times 2 is 22. 20 minus 4 is 16. Like so. Okay. And see, this is the important thing, right? I've now spotted which class Michael is in. See? So I saw something. I was like, I don't know how I'm going to work that out. Worked out the answer, now I know. So the question is, how do I know? Highest score, 22 and 16. Michael got 17. So he cannot be in class Y. In other words, he must be in class X, because 17 is bigger than highest score in Y. And again, I do see this happen a lot where some students, they don't want to try things. So they don't want to just keep going until they hit a snag. Instead, they'll think ahead and they go, how am I meant to work out which class he's in? My teacher never taught me that, or something like that. Just work out some stuff and you get marks anyway. But some students really get this thing where it's like, if they don't know exactly what they need to do, then they don't want to do anything. Again, don't be afraid of failure, right? If you try something and it doesn't work, just ask for another sheet of paper and then try again. It really doesn't matter that much. So, Michael's in the top something % of performers in a class. So, what would be a good way to work this out? There's a few ways. Got my voice cracked. There's a few ways to work this out. One way is if we have a look at the quartiles, he is in the upper quartile, right? 14 or above is in the upper quartile. Now, what does the upper quartile mean? Well, that is the top 25% of data. So in other words, Michael was in the top 25% of performers. Now, I don't actually like this question because of the wording. It makes it sound like you need to work out the exact percentage. Like, because technically he's not in the top 25%. He might be in the top 22% or 20%. But they're relying on you knowing that you can't actually work out the specific percentage. However, we can look at this and say, okay, the lower quartile means you're in the top 75%, right? Because the lower quartile is the bottom 25% of the data, so you're in the top 75%. The median, well, that means you're slap bang in the middle, so top 50%, bottom 50%. Upper quartile means you're in the top 25% or the bottom 75%. So that's what they're relying on for that question for 6 marks. I actually did do it in the space they gave me. Fair enough. The diagram below shows parts of the graphs of two functions, f of x and g of x. So one's a straight line, one is a cubic curve. Find the integer value of g f minus 2. So when they say integer value, they basically mean you don't need to get an exact value. You're just getting whatever the nearest whole number is. Now, normally, what you'd do in a situation like this is you'd work out f of minus 2 by substituting. You'd sub that back into f, find that out, sub that into g, and that'll be your answer, right? So if you had the functions, you would sub it in, sub that answer in, and then sub that answer in again. But, as you can see, we do not have any functions to sub in. So what we need to do is actually just look at the graph. So first of all, f of minus 2, well, if I look at the graph, when x is minus 2, that's fairly clear that the function is 0. So now I take that value and I sub it into f again. So we've done the first f. We're doing the next f now. When f is 0, it goes through 6. So now we've done the second f. So now we're doing g of 6. So now look at g, the thing. So now we're going to have to actually do something. I'm pretty sure that's going to be a 2, right? Yeah, let's say 2. And that's it. 3 marks because you have 3 substitutions. So if you really want to be super rigorous, you can write then, therefore GFF minus 2 equals 2. But again, if you can't substitute, you can always use graphs. Again, there's nothing, even though your teacher may never have shown you it, you should know how to read values from graphs, which is essentially what they're testing here. It's just knowing to do that. So don't rely on previous examples to help you all the time, especially when you're aiming for grade 9. There's always one question that just looks like it's going to give you a headache. So there are 2 touching circles, and it's always to do with circles. Anyways, circle 1 and circle 2. It's fairly clear that this over here is circle 1 and this is circle 2. It gives us the radii or radius, whatever you... Wait, no, the radii. So 5 and 4. That's how I know this was circle 1, because the radius was bigger, which means it has to be the bigger circle. C is the centre of circle 2, obviously. AB lies on the diameter of circle 1. Yeah, AB is going through the diameter. AB is also perpendicular to a line passing through the centre. Okay, this is actually a deceptively useful piece of information. AC and BC are tangents to circle 1 and pass through centre C. AC and BC are tangents. Yeah, cool. Okay, yep, I've got it. Find the area of the triangle ABC. So this is a big triangle. Now, that does look really complicated, and almost always in questions like this, almost always, you're going to be using the fact that, well, a couple of things. The first one is this line made me this line made me pretty happy, because what they're trying to give you a hint, and it's very rare that the exam board are nice and merciful, but they're trying to tell you to do, well, okay, it's a bit lower than that, to do that. And why is that? So you think, why are they giving that information? Well, this goes straight from the centre of one circle to the centre of the other, right? And they're touching. So this part of this is the radius of the first circle. That's 5 centimetres. This part is another 4 centimetres. So this total line is actually 9 centimetres long. So we have our first number. Now, if you remember how to do the area of a triangle, you need the perpendicular height and then the base. So we've actually worked out one of the 2 things we need. So just as a reminder, I know this sounds really sarcastic, but it's half base times height. But remember, the height has to be perpendicular. So we've actually already gotten one of the 2 things that we need. Super, super useful. Okay, so we've used that information and it proved very fruitful indeed. Now, the next thing I look at is this. Bear in mind, a lot of this information we have used, right? Like I have technically used the radii of both of these. The fact that it's the center I have technically used because I said that this line was going through the centers of both circles. So all of this, like, we have used it, technically speaking. But those last two are really interesting. So what is important about tangents when you're talking about circles? Well, they're perpendicular, right? So God, that was terrible. Yeah, let's undo that and actually give it a better go. There we go. Right angle and a right angle. And yeah, what another thing that we can do. This is pretty exciting. But the reason why I wanted to do that is we need to work out the coordinates of point A and B, which, as you can see, are the y-intercepts of both of these graphs, right? So it's the y-intercept, y-intercept. Once we work that out, working out the base is trivial. We just need to find the difference in the two coordinates and we're done. Which is easy. That's not too bad. But we do not, to work out the equation of these lines, we need the gradients, which we can and can't work out because we know that they're perpendicular, so we know it's the negative reciprocal, but we don't have any coordinates, which we do need to work out the equation of the line anyway. So we need to think about what we can do with the information we have. Just before we go on, it actually might be a good idea for me to label some of these points. So I'm actually thinking of two different ways of doing this. One way is to just work out this base here and do it from there. There's another way I'm thinking of, which I'm going to keep it to myself for now. Actually, no, I'm not. The other way is, because we've split this directly in half, we could just work out the area of the top triangle and then work out the area and then just double it. So the question is, which one's more useful? Well, the fact that they're perpendicular is going to help in a second, because we need to use some trigonometry or Pythagoras to work out some of the other information that we need, because we don't have enough information at the moment, simply put. So if I work out, okay, so because we couldn't use the fact that we can't use the y-intercept by using the equation of a straight line, there is another way we could work out the length of this line. What I'm going to do is, if I look at this angle here, right, that angle is in this triangle, but it's also in this triangle, both of which are perpendicular. So what I'm going to do, I'm going to do something very clever. I'm going to work out the angle using this inside triangle, DEC. That angle will be the exact same as ADC. And what I'll be able to do is work out the length AD, which will be the same as the length of DB. That's probably the best way we can do it. Okay, so question is, what is this red length? Well, if you remember, it's just going to be the radius of the circle. So it's actually going to be 5 centimeters. So if I want to work out that angle theta, it is opposite over hypotenuse. So that means it will be sine theta equals opposite, so 5 over hypotenuse 9. Theta equals inverse sine of 5 over 9. Let's use our calculator. Change it back to the normal setting. Inverse sine 5 over 9 gives me 33. I'm just going to call it 33.7 degrees. I wonder if I should do a separate video on this question. This is a really good question. Once I've done that, I'm now going to get rid of this very carefully. Ooh, okay, I'm going to leave. I'm not going to push it. Now I have theta, so I'm going to get rid of that. It's 33.7, and I want the side AD. So let's just call it, I don't know, x again. Well, that's fine, right? It's opposite over adjacent. It's tan. So tan 33.7 equals opposite over adjacent. So x over 9. Because again, this is still perpendicular. I really think I should do a video on this one. This is a really good question. Which equals, well, I mean, I'm going to work it out on the calculator. I'm not going to do it in my head. 6.01. Do I want to keep it super accurate? Let's keep it super accurate. Let's do 6.01 centimeters to 3SF, which means the area of ADC is half base times height. Actually, no, I should label it. I'm getting too excited. All right, 6.01, which is going to be half 6.01 times 9. And that means the area of ABC is 2 times that entire thing. Beautiful. So 0.5 times answer times 9. Take that, double it. 54.1 centimeters squared to 3SF. What a question. Pretty good. Yeah, that was a pretty interesting question. But again, it's using the same kind of skills that we've used before. And yeah, and as you can see, all I did is I drew all of the information out and then made a decision. The hardest part there was seeing that there were 2 triangles that used the same angle. That I can see that being a bit of a problem because we don't really use that fact very much in GCSE maths, so you won't be used to using that fact. We have the area of a parallelogram is 15 centimeters squared to the nearest integer. My voice cracked again. The shortest side of the parallelogram is 4.5 to 2SF. The longest 7.1 to 2SF. Find the largest possible size of the 2 acute angles. Okay, so if I draw out just a generic parallelogram, it doesn't have to be accurate, which is handy for me. Oh, come on. Why does this thing not autocorrect anymore? Okay, whoops. Okay. Right, let me try and draw it a bit better. Ah, there we are. Hey, there we go. Okay, so it doesn't really tell us much about this. So the area of the whole parallelogram is 15. Okay, so the shortest side is 4.5. Now, it says to a certain number of sig figs. I'm just going to write it as the normal value for now because I don't know if I want to take the upper or lower bound. I just don't know yet. Find the largest possible of the 2 acute angles. Now, if I have a look at this parallelogram, I can see that the acute angles are going to be these ones, right? And that's always true in every single parallelogram. There's 2 acute and they're always opposite to each other diagonally. And there's 2 obtuse, which are, again, they're opposite to each other. Now, if I'm looking at this, the great thing about parallelograms is you can split them directly in half and it's a line of symmetry. So this half of a parallelogram is the same as this half. Now, why is that good? Because that means each half is going to get 7.5 or 7.5 centimeters squared of this area. Okay, so that depends on if I'm taking the upper or lower bound, because again it says correct to the nearest integer, but half of that is here, half of it is here. Okay, so I'm not going to use it just yet. Find the largest size of 2 angles. Okay, so the reason why breaking into a triangle is really helpful is because when I can't work out the area of a parallelogram without working out, well, I mean, I can work out the area of a parallelogram like this, but it has nothing to do with the angle. So I could just do 4.5 times 7.1. Okay, cool. But how am I meant to work out the angles? Angles are always to do with triangles, really. So breaking in half means now I have a triangle. Now, the area of a triangle is a half, these 2 sides, and then sine of the angle between them. It's half AB sine C. So if I write that out, half AB sine C, again, it's 2 sides and the angle between them. Now, what I want to do is rearrange for sine C. So that means it would be 2 times the area over AB equals sine C, because I'm trying to work out the angle. Now, it says I want the largest size of the 2 angles. So to make it the largest, I need this to be largest. Now, how does that work? Well, I want the lowest value of A and B, and I want the biggest value of the area. Okay, because that will make that fraction the biggest, right? If I make the numerator bigger, the overall thing gets bigger. If I make the denominator smaller, it makes the overall thing bigger as well, because you're dividing by a smaller number, right? Dividing by 3 will give you a smaller answer than dividing by 2, as an example. Now I can actually do the bounds, okay? So what do I want? I want the largest bound for the area. Now, here's the really key thing here with 15 centimeters squared, and it's to the nearest integer. The biggest value is 15.5. The smallest value is 14.5. But now I'm dividing this by 2. So divided by 2, what do I get? 7.75. So that is the value I'm going to use for the area. So the area equals 7.75. A and B. It doesn't matter which way around you do it. So 4.5 to 2SF, sure. The largest possible value would be 4.55. The largest possible value would be 4.45. We want the lowest value, so I'm just going to call it A equals 4.45. Again, it doesn't matter which way around you call them, so don't worry too much. And longest is 7.1. So again, largest value is 7.15, smallest value is 7.05. Yep. And that means we're going to be using 7.05. So now we can work out C and we're done. That's it. So C is equal to the inverse sine, 2 times the area, so 2 times 7.75, over 4.45 multiplied by 7.05. That gives me my answer. 5 marks. Final question of the paper. Bob's your uncle, whatever else you want to say. Inverse sine, we have 2 times 7.75, 7.75 over 4.45 multiplied by 7.05. Close the bracket just because it makes me feel good. 29.6 blah blah blah, but it says to 3 decimal places. So that's 29.608 degrees. And that's it. So I think I would like to make individual videos on some of these questions because they are pretty in-depth. So if there's any that you're kind of unsatisfied with, you think that I maybe went a bit quickly, let me know in the comments and I will redo them. Other than that, just make sure you do all of the usual stuff. Enjoy your days and I'll see you in the next one.